This mini lesson is an introduction to logic. There's going to be a lot of vocabulary in this lesson, so I recommend if you need to stop the lesson to hit pause as you're recording definitions. You can also go to our class Quizlet page. One of the most important vocab terms in this unit is a conditional statement. We'll be using these a lot, and you'll hear these a lot in definitions and different rules we talk about in geometry. So a conditional statement is an if-then statement. All conditional statements contain a hypothesis and a conclusion. So let's look at an example. A conditional statement could be this: if I am at a high school football game, then I am cheering for Eagle Crest. So this statement can be broken down into a hypothesis and a conclusion. The very first part of the statement, if I'm at a high school football game, that is what we call the hypothesis. So the hypothesis always begins with the word if. The second part of the statement is then I am cheering for Eagle Crest. So in that second part of the statement, it always starts with the word then, and that's our conclusion. Now, there's something really important to note here, and it's whether or not a conditional statement is true. So for a conditional statement to be true, the hypothesis is true, or if the hypothesis is true, then the conclusion must always be true. Otherwise, the statement is false. So this conditional statement might not be true for everyone. It's a true statement for me because I only go to our high school football games. So if I'm at a high school football game, I'm always cheering for Eagle Crest because those are the only games I go to. And of course, I'm going to cheer for our team. This statement would not be true if I go to any other high school football game and cheer for any other team. Our next important term is the word converse. So the converse of a conditional statement is when you switch the hypothesis and the conclusion. So for example, based on the statement from the last slide, if I am cheering for Eagle Crest, then I am at a high school football game. So I've changed the order of the hypothesis and the conclusion. Now, the converse of a conditional statement is not always true, even if the conditional statement was true. So when the converse is not true, we can prove that with what we call a counterexample. So a counterexample is an instance when the hypothesis is true, but the conclusion is not. It proves that the conditional statement is not true. So the converse is still a type of conditional statement. Now this conditional statement, the converse of my original, is not true because I could be cheering for Eagle Crest at a basketball game or a volleyball game or really any of our other sports events that I could attend. Sometimes both the conditional statement and its converse are true. And when that happens, we can write what we call biconditional statements. These are going to be joined with the phrase if and only if. So let's look at an example. Here's the first conditional statement. If two angles have a sum of 90 degrees, then they are complementary. Well, we know this is true because that is the definition of what complementary angles are, and we learned that in our last unit. So let's look at the converse of this statement. If two angles are complementary, then they have a sum of 90 degrees. Again, this must always be true because that's the definition of complementary angles. So because both the first conditional statement and its converse are true, we can write a biconditional statement. So the biconditional statement will look like this. Two angles have a sum of 90 degrees if and only if they're complementary. And that language there, if and only if, that's really important. We're always going to hear that in the middle of a biconditional statement. You've reached the end of this mini lesson. I'm going to really encourage you to get on Quizlet and study the vocab that we've talked about today. It can be tricky, especially because a lot of the words sound the same and a lot of them start with the letter C. The vocab is going to be really, really critical in this logic unit.